Hello and welcome to the Eagle Connector tutorial. Here I'm going to cover some things, a couple of just things that will overall improve your design and how you use Eagle, and then also adding 3D Mechanical CAD to your parts. This will ease integration a lot and really help out whoever is dealing with your board on the mechanical side, letting them know where things are placed. And it's a good sanity check that both you then see more of which side your things on your board are, and the thickness of the components that you have, and then also that you're not putting things in the wrong side and such. So we just have a blank library here. I'm going to be making this product from TE Connectivity. This is actually an 8-pin screw terminal block. The picture here is just 4, but it's actually 8, as you can see there, 8 position. So we'll get started and we'll kind of cheat a little bit and just import a symbol. And we're just going to use the generic SparkFun Connectors 1 8-pin, just like this. Starts off, nicely for us. They have the name, everything here. One thing to note is the pin swap of these. By default, all pins are set to be 0. However, you can set them to swap level. 0 means it'll never swap with anything. And then any number that's greater than 0 will swap with any pin of the same number. So these are all 1, so any of them can be swapped. And like I said, by default, these are 0. So if you're making a wire to the board connector, where you can kind of control the order of the wires that as they go into the connector, I really recommend setting this to 1. That makes it a lot easier, because then when you're actually routing the board and you decide, oh, I don't want to have to cross these, you can just switch them. It makes it a lot easier rather than going to schematic, having to kind of mess with moving them. You can just do it while you're routing. So yeah, setting the swap level. If you're making a board-to-board connector, I don't recommend this in some cases, just because you might have an agreed pinout with someone else. So you don't want to make it easier to change that pinout and potentially mess up the which goes to which between your two boards. But something to keep in mind. So we have that. We'll go to table contents. Again, I will kind of cheat, and since this is just a generic header pin, it's the 2.54 millimeter pitch. We're just going to import that one too. There are a couple things I'll note here too. So we want, where is it? Good old. So I'm not really a fan of these. Let's see. And besides, our terminal block that we're making is actually going to be a little, it has a different kind of footprint and size to it. Another thing to note here, I have this in kind of the written tutorial. These pins are obviously sized pretty appropriately. It's pretty easy to solder to them. Sometimes you might end up with a pin where maybe your diameter is set to 55, and if this is some automated thing, or usually automated surface mount, but this is some automated thing, that an area around to solder isn't too bad. But for practical purposes, having a little more exposed copper there that you can solder to is really helpful. So this is one thing to consider, especially if you're using a footprint that's pre-made, is how much area is actually there to solder. So I'm going to keep it at 74. This is a good kind of number, and if you have questions, ask someone who's soldered some a little more. It can be tough just looking at a CAD file. So anyway, the first thing we're going to do is to draw an outline around these things. If we look here, we can probably find so A, what is the dimension? Dimension A for 8, 20.78 millimeters. Going across from left to right, I believe, okay, that is centered at the origin there. We'll just make a line and then edit the properties. So, and we'll need to have it centered on that. Oh, they do, okay, 1.5 millimeters to the left of that center pin. So, we need to switch our grid to millimeters. I'll set it to 0.5. That's a fine number for now. So like we said, our dimension right here, 1.5 ref. That's what we're going to set that to. And then we know the length of it is 20.78. So actually, let me do that quick maths. 20.78 minus 1.5 is 19.28. There's our line. We'll also get the vertical spacing. So this is saying right here 3.25 plus or minus 0.15. We'll give it a little error. We want to make sure it fits nicely. Nothing's banging right up against it, so we'll say 3.4. Again, that's down on the origin, so our Y height is nice and easy. Then let's copy this. There, set this to negative 3.4, negative 3.4. Then just need to put some lines in here between them. And on the other end. So now these lines are pretty good. I'll show you, which layer it is. One thing that's kind of critical, and it's easy when you're making a board and you're just thinking about it electrically to be like, yep, there's the connector there. But you also really need to consider which side of the board the connector's going on, and this is especially important for keyed connectors. This connector, as you can see, it's not keyed. You can the left end and the right end don't really matter. It's not like something has to plug into it a certain way. But making sure it's on the correct side of the board is pretty important. So there is another trick that we have to do that, and that is because the kind of T-place and B-place layers for the top and the bottom place, they do all right, but they're not great at differentiating. But fortunately, we have the tKeepout and bKeepout layers, and you'll notice these used on some things like default spark plug resistors. They have a bounding box going around, so we're just going to do that. This one, I guess, doesn't need to be quite as precise. But this will be a really useful indicator when you have it on a board to just, as a reminder there to yourself which side it's on. And Eagle will also tell you if you're putting something that's hitting this bounding box. And I drew it inside. It doesn't matter terribly if you're doing it outside, inside, though sometimes putting it outside lets you know if something else is getting close to it and there's not a lot of clearance between them. So I think I'll actually do that. Hard line it out. We gotta edit this again. Quick. So, back to the tKeepout layer. We'll just put our box around it for now. And then we are done right here. So save it. Actually, yeah, we haven't saved it yet. I'm going to put it in our parts library and call it something pretty descriptive. TE. We'll call it 8-pin screw. And always good to have the part number in here too, which is this. They just use numbers for all of it. And we have to connect it. Oops, gotta actually add our symbol first. Okay, and put it in there. That part doesn't really matter quite as much. Kind of orders them all nicely for us, and this is just 1 through 8, so not too bad. One thing also of note, I think we do cover this in our earlier tutorials, but by default the pins names will be something like $1. You really want to rename these to something. Usually it's just a number order. There's not too many cases. Maybe if you're making like a polarized capacitor or a diode, you want to do P and N or something like that. So here you can kind of see a preview. This is what it might look like in this schematic, and that 1 through 8 is just really clean. So yeah, we have it all connected, pretty good. So save it now for the fun part of the 3D package. So to start, we're going to do create managed library. I think you do need an Autodesk account for it in 360 or 365, something like that, integrated with Fusion and whatever. You should be able to get that through your educational email. So anyway, we have our managed library. We'll hit OK here. We don't need to view it on the web yet. It makes a kind of 3D package for us, and it just puts a box that sticks off some height only around where there are pins or pads on your footprint. So anyway, we're going to right click and do view on web. Then it's going to pull this up to our nice web viewer, and like I said, there'll be a thing here that just covers wherever there's pins on there, which isn't terribly useful. We could definitely do better than that. This is something where we'll then go to the website, download the step CAD file from it. If your part does not have an available step file, then contact your favorite member of the mechanical team and get them to make one for you. If you're feeling good, you can make one on your own too. We've already downloaded that. So we will go over here, we'll do edit, and then it'll kind of make a package and everything with it. And now we will have to add our step file for it. Step, and then I think I have it right here. And it'll take a little bit to upload it and create it, make it for a model. And then we'll have it in this 3D viewer. I think by default it'll add it to all your models, and then also insert it into your viewer here of what model you're using. So this thing will stay around. You just have to click add again. And here we have it. We're going to use the left mouse to orbit. They nicely put it on the other side of the board for us. So this is pretty common. You're going to have to move it around a little bit. You can use these 3 arrows to move it in just one direction. You can grab and move it in any direction, maybe not up, but so we first need to, when you also have these controls here if you want to set it to a certain number. So orient it in the right direction, and then try to push it over that and drop it down in there. Ideally try to get it pretty flat, and this is also a pretty good step to make sure that you got the footprint right. If the footprint looks vastly off or something like that, then the pins don't line up with the holes, you probably did something wrong. You want to check the data sheet again. So alright, I think that's about flat, kind of where we want it to be. We can leave a little gap, I guess, for maybe not holding it flush while soldering, but you should try to solder it as straight as you can. Now we just line it up with the pins. And this is where those 3 arrows right there to only move it in one direction at a time really come in handy. Go and move it too far, and move it back a little bit. So I'm thinking that looks pretty good. As you can see, our bounding box is pretty spot on with how we want it. So at this point, we are good to go, and we will do export and then LBR. And yes, now Eagle and this online Autodesk thing, it'll actually try to make a new Eagle file for you named the same thing as your footprint. This is why you really shouldn't close this out. Eagle will actually move it. It'll kind of look like it deleted it, but it's just been moved to your roaming folder. So if we go save as, you'll see it's just somewhere in the roaming folder. We'll go back to parts library and save it where we had it before. And this is something when you're using Git, you should probably commit it before, just in case you can't find it afterwards or something. But yeah, we'll save it back here. Then right click on the 3D package and hit update to latest version. And then there we have it. So now I'll just make a nice board real quick. Let's get the schematic to actually add it. So add our part here. Yeah, save it. Let's see, which one is it? Okay. I guess it looks like it's kind of been added twice. We want the one here with that model symbol. You can also see it right there, previewed. So we'll go with this one, put it in. And then we'll go to export and then step. And it'll tell you, it's exporting. So we can go back to our Eagle Home tab. And then if you scroll down here, it'll show you recent files. And it's currently generating our 3D model. When this is generated, I believe it'll be placed in our downloads folder. So we will navigate there now. Hopefully it shouldn't be too long because this is a pretty simple board. Yep, there it is, untitled.step. We'll go to our favorite step viewer. There we go. And navigate to our downloads folder, grab the step. And here we can see it with our lovely new CAD file there. As you can see, we had our top side of the board as indicated by that red box. This is really useful because then if you switch to the other side, it'll show it blue. It's on the opposite side of the board. Handy for keeping track of where it is. So, yeah. That is all for the tutorial. I hope you enjoyed it.